Good morning, good evening, good afternoon, whenever and wherever you are. My name is Anna Rochelle, and today we are going to factor special cases, but one particular piece of special cases, we are going to factor the difference of two squares. And the difference of two squares is something that's super important for us to focus on just because it shows up so often in Algebra 1, and it shows up even more in Algebra 2. And as I'm speaking about this, I'm thinking to myself, maybe we'll change some of the problems for the, last problem or the last two problems to do like more of an Algebra 2 type of uh, problem. So let's get started with the very first one, and I'll surprise you. Maybe we will, maybe we won't. Just we will. Okay, so here we go. When we're looking for the difference of two squares, we're kind of rewriting this in our minds as x squared plus 0x minus 100. So kind of like how we did a few videos back when we were working on factoring regularly, where a is equal to 1, we had to find all of the numbers that would multiply, right, to get to negative 100. And we wanted these numbers to also add to get to 0. In this case, 0, because that's the number here, but that's kind of like where we were in that very first video when we were working on where a is equal to 1. And so in this particular case, we know that 10 times 10 is 100, but we also know that if one of them is a negative number, then it'll give us negative 100, right? So I'm going to have negative 100 times positive, sorry, negative 10 times positive 10. And if you'll see that if I add negative 10 and positive 10, that'll cancel itself out. So it'll become a 0, right? So when I do open up my two sets of parentheses, I know that x times x is going to give me my x squared that I'm looking for, the one that's right here, right? And then if I add a positive 10 and a negative 10 to each of my parentheses, I'll be able to get that 0x and the negative 100. So this is kind of like where I'm going to stop for this particular type of problem. As I move forward in math, I will be able to solve these difference of two squares problems, but for right now, all we're doing is just factoring them, okay? The other piece that I want to mention is when I add this 0x, it doesn't change my problem because no matter what I put in for x, I'm going to multiply it by 0, and I'm going to like basically this is going to be a wash, right? And that's what allows me to do that. Now, this is the more basic version of solving this problem. This is like a more elementary piece, but we are not like Watson, elementary, my dear Watson. We are fancy pants algebra students, and we are fancy pants high school students. And so we're capable fully of doing a more sophisticated method. And so what this sophisticated method has us doing is we are going to identify what the perfect squares are in here, okay? So for example, 9 is a perfect square, x squared is a perfect square, and 64 is a perfect square. So if you take a look, we're looking for the squares, right? And we're also looking for the difference. So if you notice how I'm subtracting here, so I'm finding the difference of two terms, right? That and both terms happen to be perfect squares. So if I square root kind of these two terms, what I'm going to see is I'm going to have 9x squared is going to be 3x times 3x, right? Because perfect squares are actually, you're taking the same number and multiplying it together, right? And then the 64 is also the same piece. It's 8 times 8. So since I have the same exact piece, what I'm going to do is I'm going to put the 3x and the 8 into one parenthesis and the 3x and the 8 into another parenthesis. But just like any of my difference of two squares problems, I'm looking for this plus 0x. That's going to be kind of in the middle of this section here. And in order for me to be able to get this plus 0x, I need a positive 8 and a negative 8, right? And so I'm going to show you how this works. When we find the product of these two numbers, we're going to get positive 24x, right? And when we find the product of these two numbers, we're actually going to get negative 24x. And when I add these two together, I'm going to end up with a 0x. So that's kind of what I'm looking for when I'm solving these difference of two squares. Okay, and then that's how I solve it. So before you go ahead and solve this next problem, I made a mistake. It should have been 100, not 10. Okay, now I don't like how it looks. Okay, here we go. 100x squared minus 49. So let's take a look at this guy. Again, let's be a little bit more sophisticated. So let's take a look. I have a perfect square, which is 100, a perfect square, which is x squared, and a perfect square, which is 49. And I'm subtracting these two terms. So I know that 100 is 10 times 10. And I know that x squared is x times x. And I also know that 49 is 7 times 7. So I'm going to place 10x plus 7 and 10x minus 7 in each set of parentheses, call it a day, and move on to the next problem. Let's take a look at the next one. So this one is kind of like where things get a little bit trickier, right? Because first of all, yes, this is a perfect square. Yes, this is also a perfect square, but I'm not finding the difference. I'm finding the sum, right? Like this is an addition problem. Yes, this is negative, but okay. So like we did in a previous video where we found the greatest common factor before we actually factored our trinomial, we're going to do the same exact thing here. We're going to find the greatest common factor, but we're going to find it between the two terms, so the binomial instead of the trinomial, right? So I'm going to go ahead and I'm going to pull out a -1, and then I'm going to end up with x squared minus 9. Meaning I'm going to factor out a -1. And so I'm going to divide each term by -1. Well, when I have a negative divided by a negative, it's going to be positive. When I have a positive divided by a negative, it's going to be negative. So now if I take a look at this problem here, this is a perfect square and so is this. And I'm looking for the difference between the two, right? In the previous video, when we factored out a greatest common factor, and then when we factored a trinomial, right? What we did was we left this -1 piece here, and we opened up two sets of parentheses. We know that x times x is x squared, which is exactly what we want. And we know that 9 is going to be 3 times 3. We'll make one positive, one negative, and then this will be our final answer. Now, what you'll see in Algebra 2 a lot more frequently is the following, and I'm going to actually change this problem as well to give you like a little bit of a taste of what's happening. So sometimes your Algebra 2 problems will have not just squared, but to the 4th, to the 3rd, to the 5th, to the whatever power. And you're actually going to learn how to graph them. So what I want to share with you in this case is the following. Let's take a look at this. So 4 is a perfect square. X to the 4th is actually also a perfect square. If we were to break apart like what 4x to the 4th is made out of, it would be, it would be 2 times 2 and then times 4 x's, right? So if I were to take one thing and like kind of like break it apart, divvy it apart into two separate numbers, I would get a 2 and a 2 in one of them, right? In each of the numbers. Then I would get an x and an x. And then I would take another x and x, right? Well, usually we don't write 2xx, right? Usually we'll write 2x to the second and 2x to the second. And if you want, you can go ahead and multiply this out, right? 2 times 2 is 4. Well, we got that, right? And then x to the second times x to the second, we're going to multiply those exponents, and we're going to get x to the 4th. If you do need some help with exponents, I do have a set of videos on exponents, so definitely go ahead and check those out. If you can't find those, just go ahead and send me an email or comment on the video, and I'll reach out to you with what I have. Okay. So now I know that 4x to the 4th is 2x squared and 2x squared. And then I know that 81 is going to be 9 times 9, right? So then I've got here 2x squared in one parenthesis and 2x squared in another parenthesis. And then I've got a positive 9 and a negative 9. Another reason why you would want to do positive and negative 9 in order to get your final answer is as follows. We're looking for factors of negative 81. When we look for factors of a negative number, one of them will always have to be negative and the other will have to be positive, right? So that's kind of where I'm coming from with this whole positive negative angle. Okay. So let's take a look at problem 6. Now, again, if you're not pausing this video at any moment in time, this is the right time to pause this video. Go ahead, pause it, see what you can do on your own, and then come back to me, okay? So the very first thing that you're going to do is you're going to take this negative, you're going to factor it out. So I'm going to divide each of my terms by -1, and I'm going to leave it as -1 on the outside, and then I'm going to end up with 4x squared minus 36, okay? And then I'm going to notice that, hey, all of these are actually perfect squares, right? The 4 is a perfect square, the x squared, and the 36. So then what I'm going to do is I'm going to factor this difference of 2 squares. I'm going to have one set of parentheses here, one set of parentheses here. I know that 4x squared is going to be just 2x and 2x. And I know that 36 is 6 and -6. So positive 6, -6. And ta-da! Oh, and now I don't like that they're both blue. Oh, well. Anyway, I will see you in another factoring video. Bye.